Right, welcome to the numerical analysis course. In the last lecture we studied Newton's forward interpolation method, and in this lecture we'll study the sister method, Newton's backward interpolation method, not very different from the forward interpolation method. Right, the thing that is given is the same as it is given in Newton's forward interpolation method, the set of data points, and y, the second set, is the function of x. And for any given value of x naught that is in between the two given values of x, maybe it can be between x2 and x1 or x3 and x2 or x4 and x3 and so on, we have to find the corresponding value of y, and we call it y naught. Right, in the forward method we studied an expression like this, but in backward method we have an expression that is slightly different from the method from the formula that we studied for forward method. Right, now let's see what's the difference. This base value yp in the forward method, this yp is the value of y just before y naught. Here it is after y naught. This is the first difference. Yp, it is after y naught. This is value of y after y naught, whereas in case of the forward method it is before y naught. This is the first difference. The second difference is the value of p. In fact, the value of p, the formula is the same, but it comes out to be negative. Right, the formula is the same, but it comes out to be negative. We compute the differences, but the same differences we call them as nabla y instead of del y. The values are the same, nabla y. Yi minus 1. Right, and that's all. And nabla and y are computed from table, but now we will be moving upward. But in case of the forward method, we moved downwards along a diagonal. In this method, we'll move upward along the diagonal. So this is the difference, very small differences. The method is almost the same. So we'll be working with the same example that we worked with when we were studying Newton's forward method. Right, so given this sine of x is a function of x, and given this table, we have computed nabla, computing y of I minus y of I minus y of I plus 1 at each stage. The same as we did for the forward method. So now we are supposed to find f of 45, the value in between 30 and 60. So the base value now would be 60, but in case of the forward method it was 30. It was just before, but in this method it is just after. So the first difference, computing f of 45, the 60 would be the base value, the value just after y naught. Similarly, xb would be the corresponding value, the value corresponding to yb. So 45 minus 60 divided by 30, xi minus 1, it comes out to be minus 0.5, but it is minus here. See the difference. It was positive in case of the forward interpolation method, but here it is negative. Right, so that's all. And now let's work with finding del y not given this by working on this table. So 45, the value just after 45 is 60. So we'll start from 60. This is our yp, and then we'll move along the diagonal. And then we will move along the diagonal this way. So we will be computing yp. The corresponding yp is 0.866 base value. The base value is after y naught in this case. Plus p is minus 0.5. Nabla y is 0.366 plus p into p plus 1. It was p minus 1 in the previous case. In case of forward method, this is p minus 1. This is minus 0.5 plus 1 divided by 2 factorial times nabla squared by minus 0.134. That's all. And once we solve it, It comes out to be 0.699, approximately 0.7, and we know that sine of 45 using calculator, it can be computed and comes out to be, can be computed using a calculator and comes out to be 0.707. So this value computed using Newton's backward interpolation method for sine 45 is very close, very close to its actual value, right? And the next is computing f of 10 degrees. This one, we are supposed to find this f of 10 degrees. For that, x naught is not 10, not 45, it is 10. What would be xb? Xb would be the value just after the value of x that we are supposed to find, for which we are supposed to find the value of y. So the next, not the previous x, but the next x. The next x is 30. This is the difference. In case of Newton's forward interpolation method, the base value is the previous value, but here the base value is the next value. Right, then it is 10 minus 30, that is 20, divided by 30 is minus 2/3. And then we are all set. We are all set to compute. We will be going this way. Using the base value, we'll go first, we'll go horizontally and then diagonally. Right. So it can be computed like this. YB, the base value 30, the value of y is 0.5. Plus P is minus 2/3. Nebula y is 0.5. And then we don't have any value, so plus 0, all zeros. So it comes out to be 0.5 minus 0.165. So it comes out to be 0.17, where sine of 10 computed using calculator, it also comes out to be 0.17. So it's exactly the same that we calculate using the calculator. So this interpolation method works very fine. Right, that's all for this lecture. Thank you.